Hello wonderful person, this is Anton, and today we're going to be talking about what seems to be the creation of the most accurate clock on the planet. The clock that's so accurate that even since the beginning of the universe, it would have only shifted by a few milliseconds. Which implies that it would take around 1 trillion years for this clock to be wrong by 1 second. But just in general, let's also talk about the history of timekeeping and how our timekeeping devices advanced throughout the last few centuries. And today we believe that keeping track of time or timekeeping most likely began with the Egyptians and the Babylonians around 5,000 years ago. Babylonians, for example, had this really complex system of keeping track of time, which was mostly used for all sorts of communal activities, all sorts of public events, and to essentially schedule different things that related around trade and also harvesting and planting of various crops. And most of this was usually done using sundials, like this one right here. This is from Egypt, which would essentially create a shadow that could then be used to track time in the day, which was also connected to a larger calendar, which normally was some sort of a really complex star chart that involved observing the stars and measuring various dates, seasons, and so on. But since sundials only worked in the morning, the night alternative for this was the so-called water clock. This usually used the dripping water to try to mark certain periods of time in order to measure times at night as well. But as you can probably imagine, all of this was extremely inaccurate, and it was relatively easy to make a mistake or possibly even have some sort of a major miscalculation in the dates, time, and so on. I mean, for example, if you suddenly broke your water clock, or if suddenly your sundial was stolen or disappeared, well, that means that you couldn't really keep track of time for quite a while. Now, at some point, the Egyptians and some other civilizations also started using the so-called hourglass, which was actually a very accurate way of keeping track of certain periods of time, but eventually even this wasn't really enough. But unfortunately, for centuries, there really wasn't any new technology coming up until about early 1200s. In 13th century, in this particular place right here, known as the Dunstable Priory in England, we have the appearance of what seems to be the first ever mechanical clock. This was a weight-driven clock, and were most likely used in this particular church to keep track of time when, for example, the preacher was delivering a sermon or during the practice of the choir. You can actually learn more about all of this in the article I'm posting in the description below. But within only a few decades after this, as the trade around Europe started to pick up, the need for timekeeping and the need for precise timekeeping, especially for example, keeping your shop open or for conducting other types of trades, created a major need for new types of clocks and a lot of accurate measurements. At this point, a lot of new clocks started to be developed by various artisans, and I think one of the most famous ones was probably this one right here in Prague. But interestingly, because all of them operated with a relatively similar mechanism where they actually used to strike a bell to announce certain time, the word for these devices became clocka, which is basically Latin for a bell. And that's of course why we call clocks today. It's just because of the historical reference. But up until mid-1600s, all of the clocks were relatively inaccurate still. As a matter of fact, most of them would have a few minutes of difference after a single day. And so the need for precision became quite important, especially as we started to colonize and explore the world using relatively complex pathways across the oceans. In this case, clocks became paramount for navigation and for accuracy of knowing exactly where you were. Now, around 1637, the famous Galileo Galilei proposed the first ever pendulum clock, which was physically created by another astronomer, Christian Huygens, only a few decades later, in 1656. And one of the reasons it was actually the astronomers that created these relatively accurate clocks was because they were having trouble keeping track of objects in the night skies. Every single night, if you didn't have an accurate clock, you would actually not know what you were looking at the night before, and you would have trouble finding the same star. Mostly because it was very difficult to know back then what time it was at night. And so both astronomers, and actually several other astronomers, spent a lot of time, actually decades, trying to develop a relatively accurate system of keeping track of time at night. And they essentially succeeded with the invention of the first pendulum clocks, which actually were relatively accurate up until approximately 150 years ago. So these were used for several hundred years. And so interestingly, it was on Christmas Day of 1656 when the first accurate pendulum clock became available to all of the astronomers. And this, of course, was also the beginning of the age of precise observations of motions of different stars, comets, and so on across the night skies. And what's really amazing about this new discovery is that it was essentially at least 100 and even up to 1,000 times more accurate than any previous clock before that. So this was an extremely groundbreaking discovery for that particular age. And so even though before that the accuracy was about 15 minutes per day, basically a typical clock would either gain or lose about 15 minutes per day, we now had an accuracy that was around 1 minute per week, and that's actually a huge improvement, especially for astronomy. And eventually, as clocks became more popular and also as they became in some sense more attractive, they even would eventually turn into a required furniture in pretty much most of the houses. And that's of course how pretty much everyone back in the days used to have these so-called grandfather clocks. But with time the mechanisms became more and more complex, and by early 1900s we had a very accurate mechanism, including this brilliant mechanism known as escapement, and even certain parts that used partial vacuum. And so by 1900s pretty much most of the astronomical observatories had these really advanced pendulum clocks that had extremely complex parts on the inside. But around the same time, actually even prior to this, we also started to discover other properties of other things, other materials. In this case, we discovered that so-called crystals of quartz were actually able to oscillate at an extremely precise frequency that could be used for certain things, for example, timekeeping. And so in 1927, the Bell Telephone Laboratories in Canada built the first official crystal quartz clock that was able to use this extremely new by then technology. These crystal clocks were extremely accurate. The error here was roughly around 1 second every 2 years or so, and so this clock was already accurate enough to be used by pretty much all of the industries on the planet. But interestingly, this technology didn't really last long. Within only a decade we've discovered that we can also use atoms. And so in this picture right here you see Jack Perry on the left and Louis Essen on the right, standing in front of the first ever cesium-133 atomic clock. The clock that's based on an extremely precise oscillation of cesium-133 atom that we've been able to calculate extremely accurate, and that has also since become essentially a standard for a lot of different measurements. For example, the second today is described in terms of the oscillations of this particular atom. And what's even more interesting is that cesium oscillations are even used to calculate some of the other units, including meter, the unit of length. So in that sense, this is an extremely important discovery and helped us improve the accuracy of a lot of different measurements around the planet. That number, or that oscillation, is the number you see on the screen, and this is the number that we use for a lot of calculations today. As a matter of fact, most atomic clocks today use cesium-133 and this number to calculate all of the time around the planet. Every satellite that we use, every atomic clock on the planet, they all use this standard. And though since then we've had propositions of, for example, using pulsars or neutron stars for more precise time measurements, because in some sense they can actually be more precise than the cesium clock, and at least one paper even proposed using this white dwarf as the most accurate optical clock, it would still be much easier for us to just use cesium-133, mostly because it's readily available and also because it's a lot easier to keep track of any kind of errors. With a white dwarf, especially if it's just a single object, it means that at some point when the Earth is spinning around, it would be invisible to some of the observers on the planet, and so in that sense it's not really the best solution. But the atomic clocks are still not perfectly accurate, mostly because when the light is emitted by the atom itself, it causes the atom to recoil just slightly, and because of this, it introduces tiny shifts of atoms and thus introduces these tiny mistakes that can add up with time. But what's the approximate accuracy here? Well, every few million years we expect an atomic clock to lose approximately 1 second. And the thing is, the scientists have been trying to improve all of this by, first of all, cooling down cesium atoms and making them stop moving so much, but that's still not really that accurate for scientific purposes. And in this case, the scientists were finally able to solve this issue by introducing a little bit of quantum mechanics. And so the scientists behind the paper you can find in the description below were able to create a really accurate cesium-133 clock by entangling several different atoms using lasers and using the phenomenon known as quantum entanglement. In other words, they were able to connect several atoms and make them act as one. And because of this, the tiny shifts of individual atoms can now become kind of averaged out, thus removing any errors that we previously had. And this new clock is basically the most accurate clock ever made. If it was operating since the beginning of the universe, so basically for the past 14 billion years, it would have only made approximately 0.1 second mistake. So that's about 100 milliseconds per 13 to maybe 14 billion years. And what's more is that this is a scalable technique. So in other words, by adding even more atoms and by adding more entanglement, we can make this clock even more accurate. And so in that sense, this is actually a completely new technique that allows us to measure time with such extreme precision that it would also allow us to recalculate a lot of different units and create some of the most precise measurements humanity has ever had. This of course includes things like seconds, but also things like units of measurements of length, of weight, and of course of energy. So in that sense, the accuracy here is completely mind-blowing. But what's interesting is that all of these advances, for the most part, have really been done to help us with different astronomical problems. Even though all of this started with, for example, Huygens and Galileo, who essentially just wanted to be able to observe comets and stars better, now we need this precision to be able to know exactly where satellites are in space, mostly because all of our satellite technology depends on extremely precise atomic clocks. Without having this precision, we actually will not be able to communicate or use any satellites. And this is of course yet another thing that astronomy is good for. It introduces these incredible concepts and incredible new techniques that are then used by everyone around the planet. But I guess for now that's kind of all I wanted to mention in this video. I wanted to take you on this historical trip and explain to you how humanity used to keep track of time and what we can do now with these new extremely precise clocks. But we'll actually continue this and talk a little bit more about all of this in one of the future videos. So make sure to subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and support this channel on Patreon or by buying the Wonderful Person t-shirt you can find in the description. I'll see you tomorrow, space out, and as always, bye bye.